Hi everyone, welcome to our first video of the year, 2.1 functions. So today's an asynchronous day. These videos will be short. I'm not going to go over every single example in the book. I will go over what are some of the harder problems. The main point of today's lesson is domain and range. Domain, X. Range, Y. Every value in the domain, there is one unique value in the range. That is a function. Every value in the domain, you guys are used to saying for every input there's one output, and that's true, but you are in like really big kid math now. We don't say input and output, we say domain and range. For every value in the domain, there is a unique value in the range. Okay, so I'm clearly out of practice with my handwriting. This is the first video I've done in a while, so be patient. Domain and range are important because, well, they determine functionality, but the domain is determined by where the variables lie in the equation. If you have variables underneath a square root, domain issues arise. If you have variables in a denominator, domain issues arise. If you have variables in a log, domain issues arise. So, for example, if I give you, here, let's do find the domain. Wow, that's some pretty bad handwriting. Find the domain. So let's say I give you the f of x is x squared minus 7x. Domain, all real numbers. There, x can be anything I want. There's no denominator, there's no log, there's no root, we're all good. So all real numbers. That's the symbol for all real numbers. Okay, what about something like, oh, and by the way, this is a function. So what if I give you the f of x is, how about x over x minus 3? It's function notation, but this is not a function. This is function notation, but, oh, sorry, it is a function. I lied, I'm already out of practice. It is a function, but it's not continuous. Whoa, this is a rational function. It has asymptotes. It has a horizontal asymptote where y is 1. It has a vertical asymptote at x equals 3. So here, if you look at the denominator, if the denominator is 0, bad, bad, bad. You can never have 0 in your denominator, ever. So if you take the denominator and set it equal to 0, that will tell you where are those bad values of x? Where do those issues arise? X is equal to 3 is where the issue arises. So you'll say x, sometimes you'll see it x not equal to 3. That's sometimes how you'll see the notation written. So I tend to just write all real numbers, x not equal to 3. Sometimes you'll see it written as negative infinity, 3 in union with 3 infinity. That to me is a lot of extra writing. Which way is best? It doesn't matter. I think the back of your book does it this way, and then I tend to do it that way. Okay, so let's do something like, let's find the domain of, oh, I like this one. Again, let's find the domain of, how about the square root of d plus 4 over d minus 7. Okay, so we have two problems going on here. First of all, the denominator is an issue. Denominator can never be 0. So what value of d makes the denominator 0? That would be 7. So if d equals 7, the function is undefined. So if d is 7, 0 in the denominator, no, can't do. Then you look at the numerator. Well, you can have 0 in the numerator, that's no problem. 0 divided by anything except 0 is 0, so you don't have to worry about it. But the issue is the square root. Square roots cause problems. If you have a square root of a negative, it becomes imaginary, and then that's a whole other ballgame. We don't talk about real graphing and imaginary graphing mixed together. We're just going to look at the real system. So d plus 4 must be greater than or equal to 0. If d is negative 7, nope, no, can't do. If d is negative 20, no. If d is negative 5, we're getting close. If d is negative 4, we're good to go. So d must be greater than or equal to negative 4. Okay, great. D is greater than or equal to negative 4, but you got that issue with the 7. Let's just take a quick look at the number line. You don't have to draw a number line. I'm just drawing it to help you see what's going on. Greater than or equal to, closed, but you can't be 7. So, stop, keep going. So, I would write my domain here as, I think I'm going to write this with interval notation. Included negative 4 up to 7 in union with 7 to infinity. This might be new notation for you. Bracket, those values are included. So, or equal to. Greater than or equal to. Those are included. Not included would be parentheses. So here we said, okay, 7. If there were no numerator, if the numerator was just 4, let's say, then we would say, okay, you could be anything but 7. I would stick to notation like this. I would have said, okay, real number is not equal to 7. But you've got this whole thing allowed, and then you got to throw that 7 out of the picture. So not included. And. Infinity, negative infinity, never, ever, ever included. Always parentheses. Always. Okay, some funky notation, some plugging in that you've already done before. So let's do some evaluating of some functions. Again, this is really just a crash course. I would hope that some of this is review, but I don't want to give you a half-hour video either because you'll be falling asleep if you're not already. How does your book write it? Okay, let's do f of x is 3x squared minus 2. G of x is, how about x over x plus 1? Okay, so I want you to find the f of 2. Plug in, you should get 4, 12, 10. Just straight plug in. If I ask you to find the f of g of 6, find the g of 6. So the g of 6 is 6/7. I made up some pretty crappy numbers. The g of 6 is 6/7, and now the f of that is going to be 3 times 6/7 squared minus 2, which you can figure that out. Plug it into your calculator or whatever. Funky notation that you're going to see is this. Oh, that's a bad color. That is a bad color. Well, it's not really a bad color. It's just a bad color on the board. The f of g of x, you are going to see written like this. It looks like fog. This is not multiplication. It's an open circle. It looks like a degree symbol. That is the f of g of x. That's composition. Okay? That's composition. the f of x divided by the g of x, you will see written as parenthesis fg of x. Okay, so those notations mean exactly the same thing. They're just fancy, trying to get you guys used to fancier notation. So let's do one of these. Let's say that the f of x is x minus 3, and the g of x is, how about x plus 7, something very basic. So the f of g of x means the f of the g of x, which is x plus 4. By the way, if you see me make a mistake in the video, please send me an email politely pointing out that I've made a mistake. And the f of g of x is x minus 3 over x plus 7. Okay? This is what most of your homework is on, but there is one thing that I want to go over that is new, and that is slope. Okay, whatever, we've done slope before, but we're taking it to a whole new level. It's called the slope of the difference quotient, which is slope. Okay, here we go. By the way, this is on page 58. That's another bad color. They're actually not bad colors, they're quite pretty, but this is something that's going to come up frequently over the whole year, over the whole year. So the difference quotient, written many ways, but this is the first way we're going to learn it. The f of x plus h minus the f of x all over h. H not equal to 0. Okay. What is this? So essentially, this is going to lead us to, down the road, slope of tangent lines. Well, who cares about the slope of a tangent line? But the slope of a tangent line is actually going to be known as the derivative when we get to calculus. And the derivative is going to let us know the velocity of a particle. So I promise you that it is, whatever date today is, the 19th, I guess it is. As we go down by May 19th, it's going to be like, oh, wow, that's pretty cool. We're talking about acceleration and velocity of particles. So math does have some use. Okay, so I want you to evaluate. Let's just go for the gusto. This is number 88. I'm giving you that the function is 5x over x minus 4. I use a lot of the same problems from the book. All right, so I want you to find the difference quotient. F of x, f of x. Cool, I already know that. H is just a variable. The f of x plus h. Okay, so when I wanted you to find the f of x plus 7, you plugged x plus 7 into the f function. So if I want you to find the f of x plus h, I'm going to plug x plus h into the function, not h, x plus h. So the f of x plus h is 5 parentheses x plus h over x plus h minus 4. X came out, x plus h went in. X came out, x plus h went in. So this is the f of x plus h. Okay. Minus the f of x, which is 5x over x minus 4, all over h. So let me try and get a different color here. So this right here is the f of x plus h. this right here is the f of x, and then this is h. Okay? All right, let's start doing some math. This is probably going to be a little gnarly. Here we go. I don't know if I'm going to distribute or not. I'm not going to distribute. Here we have a complex fraction. Remember Algebra 2 honors, how much you guys love your complex fractions. My complex fraction is x plus h minus 4 times x minus 4. X plus h minus 4 times x minus 4. So I'm going to rewrite this so I have a little bit more room. I'm going to leave some space, and I'm going to hope that I'm still in the screen. It's been a long time. Okay. This has to get multiplied by x plus h minus 4 times x minus 4 over 1. This is going to get multiplied by x plus h minus 4, x minus 4 over 1. This is going to get multiplied by x plus h minus 4, x minus 4. Everything gets multiplied by the common denominator. And the whole point of that is, watch this, x plus h minus 4, x plus h minus 4 reduces. Those of you who didn't have me last year, like, please don't say cancel. It is not a proper mathematical operation. We reduce, we don't cancel. So this is going to be x minus 4 times 5, x plus h, minus the x minus 4 is reduced, and we get 5x plus h minus 4 all over x plus h minus 4 times x minus 4. You cannot cross off the x minus 4's order of operations. You have to simplify, then subtract. Now I'm going to do some multiplying out. Oh, okay. This is going to be 5x. Distributed, I got 5x minus 20. I know I'm going kind of fast. You can pause the video. Five x times x is 5x squared. 5x times h is 5xh. Negative 5x times negative 4 is positive 20x. All over. Not going to multiply out the denominator. Well, lo and behold, look what happens in the numerator. 5x squared minus 5x squared. Negative 20x, positive 20x. So you have negative 5xh, is that right? 5x, no, this should be positive 5xh. 5x, yeah. Positive 5xh, negative 5xh. So you are left with negative 20h over x plus h minus 4 times x minus 4. Wow. Really? That's a lot to start with. I understand that it was fast. There you go. Homework. So the homework will be due Thursday or Friday, depending on what day I see you. Page 57. Number 17 to 81. EOO, every other odd. 17, 21, 25, 29. Blah, blah. And I don't believe that you have to graph I don't believe that you have to graph any of these. Okay? All right, you guys. Asynchronous lesson number 1 done. I will be posting a little something for attendance purposes. I will post that sometime today, and I'll send you a reminder to make sure you don't miss it. Have a good one.